Huge coal beds. Their extinct semi-tropical and tropical plants are found worldwide, even in Antarctica, as I mentioned. Many extinct animals, for instance, mammoths, mastodons, saber-toothed tigers, bisons, wolves, hippos, alligators, camels. Where do you think you find them frozen alive? They're in Siberia, Alaska. They're from the original creation. They are frozen in hostile Arctic region where they could not live today. And a lot of them are equatorial type of animals today, the camels, hippos, the alligators. They don't live up in Siberia. The only way they could have been there, and they're frozen alive. The temperatures change very rapidly. Trap a mammoth, to trap a hippo, or any of those other things. In fact, I had a friend, he's an old man. It took me around as a kid. He was a paleontologist. Took me around as a kid. He was Russian. He'd escaped during the Bolshevik Revolution and was up here at the University of Kansas, been at Nebraska and Oklahoma. He used to take me out, and he told me about some of those things. Some of his training was up in Siberia when he was a young man in the days of the Tsar. And I said, what was it like? And he says, well, some of our guys ate some mammoth meat. And I said, well, how'd that go? And he says, oh, they got sick. And he says, the Tsars always exported their most intelligent people to exile up there, so the IQ is about 10 or 15 points above 10 to 20 points above the rest in Russia. And the saying going around among them at that time was, well, what should you expect for the meat that's that old? But they actually ate mammoth meat. And Peter the Great had a big banquet in which they served mammoth steaks taken from these. But what are these animals doing up there? They're extinct today. They don't exist. But they were frozen alive up there a fairly short amount of time ago. Let's look at the celestial bodies. The sun, moon, and stars were immediately visible through the transparent water canopy, waters above, and the transparent atmosphere, firmament, after their creation before the flood. In other words, in this creation account, we're told that they were not only created, but you could see them immediately. Okay? The atmosphere, the region above the atmosphere will support a reasonably large amount of water, as we mentioned, creating a transparent water canopy around the earth. Since the water canopy absorbs solar radiation effectively, the warmer temperatures of the canopy could, one, hold a large amount of water, give the earth a uniform temperature, protect life from destructive radiation. Also, the transparent water canopy high above the earth cannot be, however, too dense. Reasons for this: because light from the celestial bodies would be absorbed by the water canopy and would not allow it to reach the surface of the earth. In fact, if that water canopy were dense enough, we wouldn't have any light on the earth. Let me give you an example. Sunlight is totally absorbed by 3,000 feet of clear, transparent ocean water, leaving a total darkness at 3,000 feet. That shows you how effective water, and water vapor absorbs more than solid water. So this canopy can't be too thick, or we won't even get any light on the surface of the earth, and we'll never see the sun, moon, and stars. If light travels at Einstein's speed, this is 186,000 miles per second, or 300,000 meters per second, the nearest star would not be visible before 4 years after the creation. Okay? And hardly any of the galaxies would be visible today with our telescopes after 6,000 years. Einstein's slow speed of light, and you think it's fast, but it's slow when you're looking with the universe, is a problem for a young universe theory. Velocity of light, is it a proof of an old or new universe? Let me give you a little history on the speed of light from a historical basis. Maxwell's developed his equations of electromagnetism He proposed them in 1864. Now, this is the time of the Civil War. This is 60 years before Einstein. His famous calculus equations for electromagnetism, summarizing Faraday's, Ampere's, Coulomb's, Gauss's, and Oersted's discoveries. There are 4 equations. The first 2 equations have to do with equations of state. There's no motion, just sitting there. And they say basically electrical charges are the source of electrical fields. If you integrate over them, a closed surface, electrical field, you end up with a charge inside. Charges are electrical charges are the source. However, if you do it with magnetic fields, there's no source. Magnetism has no monopoles. There's no monopole magnets. You always have to have one with 2 poles, and there's 0. When you sum over those magnetic field, there's 0 source for magnetism. You have 2 equations of dynamics, in other words, in motion. The first one says a moving magnetic field produces an electrical field, and a moving electrical field produces a magnetic field. All of our electromagnetisms, our motors, lights, and everything work off these 4 laws. This was the second greatest discovery since Newton's work with gravity and mechanics. In fact, Einstein had on his desk in front of him pictures of Newton, of Faraday, and of Maxwell. He considered it the greatest feat of modern science was Maxwell's equations. What's his derivation show? He took these equations and proved decades before Einstein what Faraday had believed, that light is an electromagnetic phenomena. It's electromagnetism in the form of, 1, electromagnetic transverse wave, and I'll show you what that means. As it travels this way, it's got electrical magnetic fields going back and forth from positive to negative deals as it moves along this way. They're orthogonal to each other and to the direction of travel. And secondly, that the speed, it was traveling in a vacuum at a speed that he determined. C, you know, is the speed of light. Or c squared, like E equals mc squared. C squared is equal to 1 over these 2 deals. C is the speed of light. E, or epsilon naught, is the electric constant called permittivity in a vacuum, and the mu naught is the magnetic constant.